Chapter 6.5, Day 2, we're rewriting logarithmic expressions. So we're going to use properties of logs to expand log expressions first. So our goal when we're trying to expand is that we want it to look like this, so meaning that we have a single value with our logs. There are no exponents, and so we're expanding. So to do that, let's remember our properties here. So properties of logarithms. So when we're expanding, notice, so that what we're trying to do, we're at a single log and we want to expand it. So if you're multiplying, if those values are multiplying with the log, we can expand it by adding the two logs together. So we separate it, log base b of m plus log base b of n, we're expanding. Then if we're dividing, what we're going to do is we're going to subtract the m and the n, right? So log base b of m minus log base b of n. So when we're dividing, we subtract the logs. Then if it's raised to a power, we're going to multiply that n, so it goes to the front, and then it multiplies to that entire log. So let's use that for these examples. So use the properties of log to expand. So first of all, we have natural log of 5x to the 7 over y. So the first thing I notice is number 1 is the division. So let's start with that. When we're dividing, we're going to subtract these natural logs. So it's natural log of 5x to the 7 minus natural log of y. And so the natural log of y is done. Okay, so there's no more work that we need to do there. And so let's look at this one, natural log of 5x to the 7. So what we want to do here is we want to separate this. And so when we're multiplying, what we're going to do is we're going to add the logs. Now we have to be careful that we don't want to move that power yet, because that 7 only belongs with the x. So you want to be careful. It only belongs to that one. So let's separate this first. Natural log of 5 plus natural log of x to the 7 minus natural log of y. So now this power can go to the front. So this is natural log of 5 plus 7 natural log of x minus natural log of y. And so that is expanded completely. So try out these examples, number 5 and number 6. Expand each log expression. So let me walk through this. Log base 6 of 3, and then we're multiplying, so that means I'm going to add those logs. Log base 6 of x to the 4th. So next, what we're going to do is log base 6 of 3 is done, but log base 6 of x to the 4th, that's going to go in the front. So again, the 4 only belongs to the x, so it doesn't belong to the 3, so we do not put it together. So therefore, this is log base 6 of 3 plus 4 times log base 6 of x, and that is expanded completely. Now let's try number 6. So before we go on to that, so I want you to notice that we have 12 to the x here. So anything with a negative in front of the log or the natural log, that tells us that it's in the denominator, okay? So this y is in the denominator. The natural log of 5 plus the 7 natural log of x, they're positive. So it tells us that's in the numerator here. So anything with a negative is going to be in the denominator. So really, really important, and you'll see in a second. So we're going to separate this. We look at the division first. We have natural log of 5. Dividing means we subtract natural log of 12x. So the natural log of 5 is good. That one is done. So then let's take a look at natural log of 12x. So we need to separate that. So this becomes, I'm going to put parentheses. So natural log of 12 plus natural log of x. So put parentheses because they're multiplying. Now the reason why I do that is because it's important to remember that you need to distribute this negative to the front and the back. So this becomes natural log of 5 minus natural log of 12 minus natural log of x. So this is the correct expanding of this log expression. So the reason why that is, again, if you look at it, the negatives tell me it is in the denominator. The 12 and the x is in the denominator, which is true here. The 5 is in the numerator. Now, if you left it alone, so if you decided to do this, natural log of 5 minus natural log of 12x, and then you didn't distribute, you just said natural log of 12 plus natural log of x. If I were to put that back together, I would look at this and go, oh, so those are positive. So that tells me it's in the top, so I would put 5x, and the negative 12 is in the denominator, and that would go in the bottom. So did we get what we started with? We did not, right? The x is in the wrong position. So that's why it's so important to put that parentheses there. It changes the value. So you cannot leave it as a positive because that x is in the denominator position. So be very careful of that. Okay, and another way to look at it is if we were to condense, right? Say we put this negative to the top. So if you think natural log of 12 to the negative 1, and then plus natural log of x to the negative 1, remember negative exponents tells us it goes in the denominator. Okay, so just kind of little things to kind of help you out, whatever makes the most sense to you as to why you should move it. So I want you to get more practice in expanding logarithmic expressions because this is new for you. So try these 4 out. So trying it out, these are the answers you should have gotten. So for letter A, you can leave it as log base 10 of 10 plus log base x. Now at the end, you could simplify. So after you expand, you could simplify. So log base 10 of 10 is 1, and then plus log of x. So this one, make sure you separate first and then move the exponent to the front. So natural log of 2 plus 6 natural log of x. For letter C, that's log base 3 of x to the 4th over 3y cubed. This is the same example that we did earlier. You need to make sure and put parentheses for that denominator and then distribute the negative. So you can leave the answer like this, or you could always simplify this log base 3 of 3 at the end, and that becomes a 1. Okay, so just in case Big Ideas does want that answer, but this is okay here. Letter D, remembering the square root. Square root is really a half, an exponent of a half, a rational exponent, and it belongs to the entire 3y squared. So then you move that to the front, and then you have 1/2 natural log of 3y squared. It belongs to both the 3 and the y squared. So when you separate it, so we put 1/2 times natural log of 3 plus natural log of y squared. I separated this in here. Then I'm going to distribute this 2. This 2 goes in the front, right? The 2 goes in the front. And then I did another thing where I distributed the 1/2 inside. So the 1/2 went here and here, then I put the 2 in the front, and then I simplified all the way. This is 1/2 natural log of 3 plus 2 times a half is just 1 of natural log of y.